Good morning, everyone. Welcome back. Thank you for joining us. We're glad that you're here. I'm Steve,
And I'm Scott.
and together we are Backyard Musings, the science and technology channel.
Yeah, today we're talking about our one of our mutually favorite topics, and that would be space and a couple of puff planets, which I never heard that expression before, or that anything called that. So, kind of interested in this one.
Yeah, so before we start, I just want to say I don't know how they can determine that these planets are lighter than cotton candy. These guys are 1,100 light years away, and if you recall, the only way they know is when they transit across their sun, and it has different waves and stuff. I don't know how they can determine the mass of the planet. I don't know.
So
So
it almost sounds like they're clouds, almost like
yeah, yeah,
clouds or gases.
that could be, but still, you don't know how dense the core is. I don't
Right,
know.
right.
Okay. Anyways, I don't fully understand this, but I'm the messenger. I'm not the expert. Okay. Okay. Two giant planets, lighter than cotton candy, are giving astronomers a rare new window into the origins of some of the galaxy's strangest worlds. Astronomers have identified two of the least dense giant planets ever measured. The unusual worlds belong to a rare class known as superpuff planets, and both are less dense than cotton candy. The discovery was made by an international team led by the University of Oxford, working with Université Côte d'Azur, Université de la Côte d'Azur, and the University of Birmingham. The findings were published in monthly notices of the Royal Astronomical Society, published on this year, June 25th. Would you like to know more?
Okay, the exoplanets called TOI 791b and TOI 791c. Obviously, those are what, the second and
Second
third.
and third planet from the star. Yep.
Okay. They circle an F7 type dwarf star about little over 1,100 light years away from Earth in the southern constellation Volans.
Pretty far
VOL.
away.
Pardon me?
Pretty far away.
Yeah, because a light year is, well, I don't know, but it's yeah. So a lot of those. Both worlds are approximately the size of Jupiter, but they contain far less material than their enormous dimensions might suggest. TOI 791b has a density of only 0.038 grams per cubic centimeter, while TOI 791c has a density of 0.047 grams per cubic centimeter. Okay, for you physicists and math guys, that's, you can figure that out, but those are the numbers.
It's really small. Yeah.
Yeah.
Okay, Jupiter, by comparison, has an average density of 1.33 grams per cubic centimeter. That makes Jupiter roughly 28 to 35 times denser than the newly confirmed planets. Cotton candy typically has a density of about 0.05 grams per cubic centimeter, meaning both planets are even less dense. Earth is far more compact with a density of 5.5 grams per cubic centimeter. Let me advance this slide here. There we go. There's a little comparison chart for you.
Okay. Well, that kind of puts everything in perspective there. You can see on the bottom part of that how Earth, which we know how big Earth is, it's pretty big,
Yeah.
right? As far as we're concerned.
Yeah.
And then we go to Jupiter, which is our largest planet in our solar system, and that's a big difference.
Yeah.
And then the puff planets are the ones above, right?
Yep.
Okay. Scientists believe the two planets formed together from the same disk of gas and dust around their young host star, making them planetary siblings. They are also connected through an uncommon gravitational pattern called a 5-to-3 mean motion resonance. For every 5 trips an inner planet makes around the star, the outer planet completes almost exactly 3. So that's not really, I guess that's a 5-to-3 ratio, right?
Yeah.
Yeah, okay.
It's like distance,
Yeah.
As the planets orbit, their gravity causes them to repeatedly pull on one another. These interactions create small but detectable changes in the times when each planet crosses in front of the star. Only 4 other known planetary systems contain more than one superpuff planet. The rarity of this arrangement makes the TO1791 system an especially valuable place to investigate how such unusual worlds develop and change over time.
Hey, so do you think that these are planets that are being formed?
Well, yeah,
I mean,
in their infant stages, yeah.
right. And I mean, because of our faith, we believe that the planets, or specifically Earth, was formed over a period of seasons, right, or a period of time. And it all started with matter unformed, and they became together, and now we got what we got now. But maybe that's kind of cool. Okay, lead author Dr. George Dransfield, which we don't. You got she, her on there. What is that?
Yes, that she put her pronouns in the paper. Yeah.
Okay, so George is okay. We'll leave that one alone. Department of Physics, University of Oxford, and a presenter for BBC Sky at night, which that must be some kind of a show, right?
Yeah.
Maybe, I don't know. This is what she said. Only a handful of these super puff planets she or her said, are known, and it is even rarer to find 2 in the same system. Their extremely low densities make them fascinating targets for understanding how planetary systems form and evolve. There you go. Okay. Unquote.
TO179b and C were initially flagged as possible planets in 2019 and 2023, respectively. Volunteers made the identifications through the Planet Hunters TESS Citizen Science Project, which examines observations from NASA's Transiting Exoplanet Survey Satellite, TESS, in search of previously unknown worlds.
Astronomers later used telescopes around the world to determine the sizes and masses of the planets. Combining those measurements allowed the researchers to calculate their remarkably low densities. A planet can be detected when it moves in front of its star and blocks a small portion of the star's light. This event is known as a transit, and the amount of light lost helps astronomers estimate the planet's size.
In the TOI 791 system, scientists also noticed that the transits did not occur at perfectly regular intervals. The slight timing changes were caused by the planets pulling on each other as they traveled around the star. By studying these variations, the team estimated the mass of each world and confirmed that both planets are exceptionally diffuse.
The discovery was built on 8 years of observations from multiple facilities, including the ASTEP, which stands for Antarctic Search for Transiting Exoplanets, telescope at Concordia Station in Antarctica. I didn't even know they had maybe we've talked about it, but I didn't know they had a telescope.
I didn't know that, yeah.
Yeah, the telescope is jointly operated by researchers from the University of Côte d'Azur, the Observation de la Côte d'Azur, and international collaborators. So that sounds French, right?
Yeah.
Okay.
Yeah. Or Quebec. I don't know. Antarctica offered an important observational advantage. During winter, the region experiences months of uninterrupted darkness, allowing astronomers to watch the planets cross their star without daylight breaking up the observations. Each transit lasted more than 11 hours. These events are the longest continuous planetary transits ever fully recorded from the ground.
Scientists have not yet reached a consensus on how superpuff planets become so large while remaining so light. One prominent explanation is that these worlds are surrounded by enormous atmospheres rich in hydrogen and helium. These gaseous layers may account for a large portion of each planet's total mass while expanding its visible size dramatically.
The planets may have formed far from their star in a cold part of the protoplanetary disk. Under these conditions, gas could have cooled and accumulated quickly around a solid planetary core, creating an immense and lightweight outer envelope. The research team plans additional observations to determine how the planets formed and test competing explanations for their unusually low densities.
Professor Amaury Triad, from the University of Birmingham, the UK principal investigator of ASTEP, or ASTEP, and co-author of the study, said, "This system offers a unique laboratory for understanding how superpuff planets form and evolve. We propose to carry out space-based observations using the James Webb Space Telescope to assess if the puffy atmosphere contains carbon, nitrogen, and oxygen-bearing species, revealing new insight into how these unusual planets formed."
Studying the planets with the James Webb Space Telescope could reveal which chemicals are present in their vast atmospheres. That information may help researchers reconstruct where and under what conditions the planets originated.
Yeah, it'd be interesting to know if these guys are faith-based folks as well, right? Like I was saying earlier, when you read in Genesis, it talks about how planets were formed. I wonder if any of them are into that thought process. But anyway, pretty cool story.
I think so.
Every
Thanks for joining us, folks.
Every time I eat cotton candy, I'm going to think about the story. Okay, everybody, we'll see you later this afternoon. Thanks.